all, what is a capillary tube means? We'll get a thin glass tube, that's it. A thin glass tube is known as a capillary tube. And also in that what happens means, whenever you are just dipping that tube in water, otherwise in any other whatever the liquid we take, at that time it might rise, otherwise it might fall, otherwise it might be unstable. So those are the things we known as a capillary rise or capillary fall. So whenever you are just dipping the glass in the water, at that time what happens? Rise or fall? Rise. The water will try to go along with the glass, like this it will be. So whenever you take the glass tube in the mercury, at that time what happens means falls. The meniscus will be there like this. Whenever you take the silver tube in the water means it will be stable. It will not neither rise otherwise nor fall. And in different kind of things we will discuss about the rising and then falling. And then finally you will have the height up to which it is raised. That is a question. Main questions can be in this topic particularly. How much height it is raised, otherwise how much depth it fallen. Both are same formulas only. Formulas are same only, but the method is different. In derivation, however, method is different. I will show you that. But in calculations, both will have the same formula. Depth and all, whenever you take the mercury, at that time it will fall to what depth they will ask. Otherwise, if you take in case of water, at that time it will rise to how much they will ask. How much height it will rise to. Those are the two topics mainly in capillarity. Along with that, the theory question can be made by the angle of contact concept. Angle of contact, and then how the meniscus will be, and then which forces will be more cohesive or adhesive and all, where the resultant will come. These are important. So for that, first of all, in capillarity what will have means, we will have a very thin tube, very thin glass tube will be there. Whenever you are just dipping that that glass tube in the water, otherwise in any other liquids, that will behave differently. Nothing but in that water level, otherwise liquid level behave differently. That might be rise or that might be fall. So that is known as a capillary rise or capillarity behavior. Now in this mainly one thing will be there, that is a angle of contact. Angle of contact. What is the angle of contact means? What is the angle of contact? We know so many contacts, but angle of contact we don't know. For example, I have taken the capillary tube in the water. At that time what happens? It will rise, as I said, so that it is rising. Don't think that it is down here, it is falling. No, actually like that you don't think. Actually before it was there like this. It was there like this. After that it gone like this. Correct? You don't understand that. I know that. So many people will think that it is fallen low from here to here. Why she is telling that it is rising? Actually it is rising. Yes, Ray, I know. You will think like that only. From here it got raised. So that is a capillary rise in case of water and then glass. This is the initial state, and then now it is rise like this. This is the extra height it is going. So first of all, the angle of contact means the angle between the tangent drawn to the liquid surface and also tangent drawn to the glass surface, capillary tube surface. So here whenever I draw a tangent for the glass surface, this is a tangent it will be, and also whenever I draw a tangent to the liquid surface, this is a liquid surface tangent. So the angle between them is known as the angle of contact, theta c. Angle of contact is not critical angle, that is a theta c is the angle of contact here. The angle between tangent drawn to the liquid surface and also tangent drawn to the glass surface. That is the angle of contact. For different capillarities it will be different. For example, if I take the mercury and then glass, the meniscus like will be there. Like this it will be there. So where the angle of contact will come now? Always you have to draw the tangent to the liquid surface and then glass surface only. Glass surface I have drawn the tangent like this, and then liquid surface I have drawn the tangent like this. Now where you will get? Let me take numbers, I will give 1, 2. In 1 you will get. Yes, is that correct? Always you have to take inside of the liquid only. Is there any liquid here? You are taking in the air. You are taking the angle only, angle between them only. But you should take always inside of the liquid. See that I have taken inside only here. Angle of contact. Here also I have to take inside only. This is the theta c. Understand clearly? So you should not consider this angle. This angle will be actually 90 minus theta, that will be. Not 90 minus, 180 minus theta. 180 minus theta. So you have to consider the angle only inside of the liquid only. So the angle of contact means what? The angle drawn between the tangent of the liquid surface and then tangent of the glass surface, and also it should be where always? It should be inside of the liquid only. Clear? That is about the angle of contact. Based on this angle of contact only, we will calculate the capillary rise, and also even we can conclude that is which type of meniscus, and then we can even conclude that which forces are more, cohesive forces or adhesive forces. What is the cohesive force? Nothing but the forces between the same molecules. Adhesive nothing but forces between the attractive forces between the different molecules. You have to take dissimilar molecules. So here this is about the angle of contact, right? That angle of contact. Angle of contact theta c. Angle of contact theta c. The angle between the tangents. The angle between the tangents. Angle between the tangents drawn to the liquid surface, drawn to the liquid surface and glass surface, liquid surface and glass surface, comma, angle of contact theta c should be always considered inside of the liquid, should be always considered inside of the liquid. Draw these two diagrams. Next, capillarity. Rising of liquid or falling when the capillary tube placed in the liquid known as capillarity. Next, meniscus. The shape of the liquid surface, in the capillary tube, Now different types of meniscus we will discuss. Based on that we will discuss the cohesive adhesive forces also. At a time we will discuss all. By comparison only we will discuss all. So first one, which meniscus this is? Which meniscus? Concave or convex or what is that? Concave. Depressed, right? That is depressed means that is a concave meniscus. This is a concave meniscus. Concave meniscus. And also, can I say here, this one is, what is the example can be? I said, when concave meniscus will come? Water and glass. The example of the concave meniscus is water and then glass. Water and glass. Now tell me, where is the angle of contact? How much it is? Acute, otherwise obtuse angle. Acute angle. Why? Because it is less than 90 degrees. Here, I said always you have to draw the angle of contact, nothing but first of all, you have to draw the tangent for the liquid surface as well as the glass surface I have drawn. And also you should consider the angle where always inside only. Most of the people don't know that, and then they will take outside directly and then they will get the answers. That's wrong. Exactly reverse answer you will get. Whatever you got plus or minus like that, you will get reverse. So here this is the angle of contact theta c inside. Can I say theta c is less than 90? Theta is obviously less than 90 only. See that very small angle here. So that theta c is less than 90. Theta c is less than 90 degrees. So the angle is which angle here? Acute angle for the concave meniscus. And also the main thing is here, which forces are more, cohesive or adhesive? Think properly. See that whenever I said you don't think that first whatever she tell and then that will be correct like that. Okay. Think and then tell. See that what happening here? Actually the water level was there like this. Now what happening? Water level is increasing. Increasing, okay. But what happening with the water and then glass? The water is trying to go along with the glass here. It is not want to go nothing but it will be there like this. Otherwise it don't want at all means it will go down only. It don't want to touch the glass. That is the main thing here. The free surface don't want to touch the glass. So based on that only we will just tell that which forces is more here. Now whenever you see this one is neither it is not going away, otherwise nor coming up, otherwise neither going down. This is what happening in the case of silver, and then this one is silver and then water. Whenever you see in this case, always the free surface is trying to get the minimum surface area. Minimum surface area means this is the mercury here. That mercury is trying to be with the mercury only. It don't want to go along with the glass, so only it is going away from the glass. Whenever it wanted to go along with that means it will go along with the glass like this. Now this is going down means it is just acquiring the minimum surface area here. Nothing but it don't want to go along with the glass. So here don't want to along with the glass means it is having which forces is more? Cohesive forces is more. Similar forces are more. Similar molecules are having more attractive force than the dissimilar molecules. So here whenever you see in this case, this water surface is whatever at the edges, if you observe at all the edges, actually it was there normally like this, but this water is wanted to go along with the glass. Wanted to go along with the glass means different molecules or same molecules are? Different molecules. The attraction between the different molecules is which one? Adhesive force. So what I can say here in this case clearly, which force is more here? Adhesive force is greater than the cohesive force. In that cohesive force and then adhesive force also we will have the resultant. I will tell about that. First of all, we will see the example. What is the example for this? Water and then glass. And also, what I can say, it is good wetting or bad wetting. See that it is going up. Going up nothing but going along with the glass means it is wetting the glass or not? Wetting the glass. So that what I can say, this example is a good wetting example. So that this is good wetting. Now whenever you see the resultant, observe the resultant correctly. Now what happening, I said the water is trying to go along with the glass. So water is trying to go along with the glass means which forces are more here? Adhesive forces are more than the cohesive forces. So that whenever you see this water surface is trying to go along with the glass means adhesive forces. Adhesive forces between what? Between what? Water and glass. So glass is pulling the water. Glass is pulling the water, nothing but the water is trying to go along with the glass. So this is the adhesive force direction. Why? Because water is pulling it. The glass is pulling it. Glass is pulling the water. So in which direction it is pulling? Nothing but it is pulling towards the walls only, obviously. So this is the adhesive force direction. Now whenever you see cohesive force between what? Only water molecules, right? Water is pulling the outer surface always. All the remaining water molecules are pulling the outer molecules always, so that they are pulling inside. See that this is going in this direction, nothing but the cohesive forces are pulling in the downward direction only, obviously, not in the straightward. Straight, whenever you compare this side as compared to this side more molecules are there here, more pulling force is acting there. So only by avoiding that force only this is going up here. This is going up, nothing but it is avoiding which force here? Cohesive force. So cohesive force, obviously which direction it is acting? Nothing but in this direction only. That is the cohesive force direction, and then this is the adhesive force direction. Whenever you see where the resultant will come, nothing but resultant will come somewhere. Which force is more here? Adhesive force is more. So resultant will also come along with the near to the adhesive force only, so that the resultant will come here somewhere. That is a resultant force Fr. So this is just based on the vector addition only, like this. Why I am drawing that outside? What is the reason? What is the reason I am drawing outside? Adhesive forces are more as compared to cohesive forces. So resultant always it will be along with the whichever the forces are more in that direction only. For example, one person is pulling me with the 10 newtons, another person is pulling me with the 5 newtons. Where I will go? 10 newtons person only, right? In the same way, my resultant direction is 10 newtons only, obviously, in that direction. Not even 10, that is 5 only, obviously, but direction is in that direction only. In the same way, here adhesive forces are more as compared to the cohesive forces, means the resultant also will be there along with which direction? Nothing but adhesive forces direction only. So that is about the resultant here. So F resultant will be always outside. Now whenever you come to the mercury and then glass, third case we will see directly. That is which type of meniscus here? See that here it is bending like this, means which type of meniscus? Convex meniscus. This is a convex meniscus. First one is finished. Now tell me about the angle of contact. Red ఏదైనా మంచిగా పడేది అంట బాబు. So always what I said, you have to draw the angle between what? Tangent drawn to the liquid surface and then glass surface. So liquid surface means this is a free surface of liquid, let us consider. This is a free surface of the liquid, and then this is a free surface of the glass here. So angle between them is how much? Theta c here. That theta c is greater than 90 or less than 90? Greater than 90, that is obtuse angle, obviously. So theta c greater than 90 degrees. And also what we said here, which example is there here? Mercury and then glass. Water and glass, and then mercury and then glass. Next, whenever you come to here, between the cohesive and then adhesive forces, which will be greater? Cohesive forces are greater than the adhesive forces. Why only? That's why only the mercury molecules are trying to go along with the mercury molecules. Here the water molecules are trying to go along with the glass molecules here. Here they don't want to go along with the glass. So only they are there with them, their own molecules only, nothing but mercury molecules with mercury molecules only. So that which forces are more here? Cohesive forces are more as compared to adhesive forces. So that Fc greater than F adhesive. That is about the cohesive and then adhesive forces. Whenever you see the resultant here, where the resultant will be there means, let me take, this is which force here? Obviously adhesive force only. Glass will trying to pull along with that direction only, adhesive force. And also where the cohesive forces are acting, nothing but into that only, into that liquid only, obviously. So that into that liquid cohesive forces are acting. Then where the resultant will be? Which is greater here? Cohesive is greater. So resultant will be where? Towards the cohesive only. So that towards the cohesive, in this direction the resultant is there. This is the Fr. So Fr will be always into the liquid. Here whenever you consider this here, Fr will be always outside of the liquid only. That is about the mercury and then glass. Example we have taken, 2 times we have taken the example. Yes, next this one is which wetting? This one is a bad wetting. Bad wetting. Why? Because whenever you see this is a glass surface, means on that whenever you just drop a mercury drop, then what happens? What happens? It will spread over. What happens? It will acquire the minimum surface area. As compared to the water, it will acquire the minimum surface area. Actually, how it will be there means it will be there like this. You are able to see that diagram? Last people, see that? It will be there like this. I have taken, this is a glass surface, glass plate. On that if I pour the mercury means like this it will be there. So it will always try to acquire the minimum surface area. Why? Because it don't want to go along with the glass. Whenever it wanted to go, then what happens means it will spread over like that. So here it is acquiring the minimum surface area, and also we have seen the angle of contact, the angle between the liquid surface and then glass surface, where the angle will come here. First elli marker lo fill cheskoni naku urgent kada. Where it will be? Outside or inside? Inside. Always you have to take. This cannot be greater than 90. That cannot be greater than 90. You have to think that. Always mercury glass nothing but the which should be there nothing but convex meniscus. In convex meniscus which angle will be there nothing but obtuse angle will be there. So that you have to take inside only. This is the angle of contact here. Theta c greater than 90. Always inside only. So that is how the glass and then mercury will be there. This is the mercury. So this is very bad wetting here. Then whenever you come to the silver and then water. This is a silver tube and then water I have taken. So whenever I take the silver and then water, at that time it is neither rising nor falling. Neither rising nor falling, nothing but what happening between the cohesive and adhesive forces. Both are equal. Cohesive force exactly equals to the adhesive force. What is the angle of contact? 90 degrees, not 0. See that. Here I have drawn a tangent to the tube and then I have drawn a tangent to the liquid surface. So what is the angle between them exactly? 90. So that theta c, angle of contact, is equals to 90. And the example is what here I said? Silver tube and then water liquid I have taken. Silver and then water. And what I said? How the related forces are related? Fc is exactly equals to cohesive force exactly equals to the adhesive forces. So only if adhesive force is greater nothing but it will go along with the tube. If cohesive forces are greater nothing but it will go along with the liquid. It is neither going nor coming. Means what happening nothing but both are balanced with each other. Fc is equals to Fa. Cohesive forces are exactly equals to the adhesive forces. So where the resultant will come here? Where the, yes, very good. Diagonally it will come. One is horizontal vector, another is vertical vector. Where the resultant will come exactly in the diagonal. In this direction the resultant will come. This is a Fr. This is which force? Nothing but this one is a adhesive force and then this one is a cohesive force in this direction. Otherwise outside it can be even. Outside is adhesive. Actually the adhesive force will be always towards the glass, right? In this direction adhesive force is there. In this direction cohesive force is there. So where you will get the resultant? Nothing but exactly in this way you will get the resultant. Not in this way, right? Yes. Here you will get. Wherever that might be inside only, right? So that this is a Fr resultant. This is about the concave and then convex and then normal meniscus, flat meniscus. So this is a flat meniscus here. Flat meniscus. And also here I said that cohesive force exactly equals to the adhesive forces. Example is water here, silver and then water I can take. So this is which type of wetting? Normal wetting, no, nothing, and we cannot say that is no wetting also even. That is just whenever I drop the water on the silver, at that time it will spread over. That's it. At that time what I can say nothing but it is wetting only. But whenever you compare as compared to the mercury and then glass, it is what? Good wetting. As compared to this one, it is excellent wetting here. Correct? This one is what happening here, water drop, whenever I pour the water drop on the glass surface, it will become like this, obviously. So that what I said, this is a good wetting I said. It is spreading over completely. Whenever I just pour the water, at that time what happening? Nothing but spreading over. Spreading over, nothing but what I can say, it is completely wetting. Completely wetting. This is good wetting. This one is bad wetting. You understand any confusion in that? You understand, right? No, I cannot understand your expressions. So only. Let me revise everything faster. So here, whenever you take the capillary tube in the water, at that time it will rises. Whenever it is rising, at that time it will have the concave meniscus. Whenever falling, it will have the convex meniscus. For the concave meniscus, always the angle of contact will be less than 90. See that less than 90 degrees is there. And also whenever you see adhesive forces are greater than the cohesive forces, so only the water is going along with the glass. So where the resultant will come? Resultant will come exactly outside. Example is what here? Water and then glass. Whenever you come to the convex meniscus, at that time we can take the example as mercury and then glass. Then what happens means mercury will not go along with the glass, so it will acquire the minimum surface area. At that time what happens, the cohesive forces are greater as compared to the adhesive forces, and the angle will be always greater than 90. That angle is known as what? Here obtuse angle we can say. And also here the mercury and then glass are example, and then cohesive forces are greater than the adhesive forces. The wetting is bad wetting. Then whenever you come to the middle case, that time flat meniscus will be there. There is no meniscus only here. So flat meniscus, no shape, nothing. So flat meniscus, and then angle of contact is how much exactly? 90 degrees. Perpendicularly both will be there. And also the examples are silver and then glass, and then cohesive forces exactly equals to the adhesive forces. And also here whenever you see the wetting, at that time it will be wetting more than the this one, whatever we have taken, the glass and then water, right? This is excellent wetting we can say. So that is about the 3 types of meniscus here. Copy out everything. Let me take 1 second. Is it wetting or not wetting first of all? Not wetting, right? Normally whenever inside is there, it is wetting at that time, but it is neither going up. Actually I have taken this one horizontally and then I have zoomed. See here what is there? Here glass is there, here also glass is there. The water is neither going up, otherwise nor falling down. I cannot say it is excellent, correct? Excellent nothing but what should happen? Entire water has to go along with the tube only here. Understand? I have taken the tube like this, and that what happens means in the first case the water is trying to go along with the tube. In the second case the mercury is trying to go away with the tube, so that only with good wetting and then bad wetting. I said this is exactly like this only. It is neither going up nor falling down. Nothing but going up means wetting, going down means not wetting. So it is there in middle only. So till wherever the liquid is there, till there only it will wet the glass. It cannot neither go upwards otherwise nor go down. So that I cannot say it is a excellent, it is a normal wetting only. I have taken horizontally and then I assumed. Nobody think that? Normal wetting ani by heart ಮಾಡಿ ಹೇಳಿದ್ಯಾ? ಹೇಳಿದ್ದೀವಾ? ಅದೇ ಜೋರ ಹೇಳಬೇಕು. ನಾನು ಹೇಳಿದ್ದೀನಾ? అరే ఇంకేసుకొచ్చావరా నువ్వు? మార్కర్స్ చేంజ్ చేయాలి. Everything you draw and then write all the points. Samantaka mani open that window. ಬಿಸಿಲು ಬರುತ್ತೇನಾ? ಎ ಸಿ ಆನ್ ಇಲ್ಲ? ಇದೇನಾ? ಆ ಥರ ಅನ್ನಿಸ್ತಾ ಇಲ್ಲ. ವೇರ್ ಇಸ್ ದಟ್ ಮೆಕ್ಯಾನಿಕ್, ಎ ಸಿ ಮೆಕ್ಯಾನಿಕ್? ಮನೆಗೆ ಹೋಗಿದ್ರಾ? ಇವರೇನಾ ಸೆಕೆಂಡ್ ಮೆಕ್ಯಾನಿಕಾ ಇವರು? ಹೌ ಮೆನಿ ಆಫ್ ಐ ಥಿಂಕ್ ಬಾಯ್ಸ್ ಆರ್ ಲೆಸ್ ಐ ಎಸ್. ಹೂ ಗಾನ್ ಟು ಹೋಮ್? ಪ್ರಜ್ವಲ? ಹೂ ಇಸ್ ದಟ್? ಎಮ್ ಆರ್ ಪಿನಾ? ಮತ್ತೆ ಅಷ್ಟೇನಾ? ಪ್ರಜ್ವಲ್ ತಣ್ಣೀರು, ಚಲನೀళ్ళు, ತರುಣ ಯಾರು? ಎಲ್ಲಿರ್ತಾರೆ? ಫಸ್ಟ್ ಬೆಂಚಾ? ಫಸ್ಟ್ ಬೆಂಚಲ್ಲಿ ಯಾರಿದಾರಪ್ಪ? ಆ ಕ್ಲಾಸಲ್ಲೆಲ್ಲ? ಓಕೆ 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 ಶಿವಾಜಿ ಮುಂದೆ ಕೂತ್ಕೊತಾರಲ್ಲ ಅವರೇನಾ? No, whichever the name I comfort with that only I will call. Shivaji, more than Shivraj, Shivaji name is a great name, re. Just accept it and then feel proud for that. Bahubali came to the class. Huh? Who is Bahubali? Chandru, na? Chandru Bakkabali. Bakkabali means Bahubali means who is having more body, and then Bakkabali nothing but who is very lean. Thangabali na? Cutie. Cutie na cute. Naughty na? Fruity. Smarty. Smarty Kiran. Wow. Right. Handsome. Yenamma? Fast irbekamma. ಇನ್ನು ಏನಣ್ಣ ಟೀ ಇದೆನ ಆ ಟೀ ಈ ಟೀ ನಾಟಿ ನೀಟಿ right here we'll just what happened re tell to us also, no, even we want to laugh. ಏನು ಶ್ರೇಯಸ್ ಏನ ಸೆನ್ಸಾರ್ ಜೋಕ್ಸಾ? See that capillary rise we'll discuss now. How much height it is raised to. So here let me take, first of all I'll take, this is the horizontal surface. From that this level is rising to how much height here? H height let us consider, and this is entirely based on the excess pressure concept only. Excess pressure I said very important thing, one is where the pressure will be more? Concave side. Concave side, not inside, not outside, always concave side. Whenever you take the bubble at that time obviously inside and then outside you will observe, but always concave side the pressure will be more as compared to the convex side. That you have to remember. Wherever it might be, water might be there or not be there, you have to always assume that concave side is more pressure as compared to the convex side. So here whenever we see the capillary rise, then after that we will see the capillary fall. Okay, first of all how much height to how much height it is rising, that height only I have to find out. This is the initial level if I consider, from that initial level to how much height the water is rising. That is what I have to find out here. H is equals to what is the value, you will find out. For that purpose, first of all I will consider 2 points here. Let me take point A just outside of the meniscus and also point B just inside of the meniscus. So where the pressure will be more? Which side it will be more, I said? Concave side, right? Concave nothing but which is there here? Concave side, point A is there. So that point A will have more pressure as compared to point B. So that what I can say here, PA greater than PB. PA greater than PB. At PA what happening, which pressure is there here? Atmospheric pressure P0 is there. I want to find out the PB value first of all. The excess pressure P excess is equals to what I can say, PA minus PB is equals to, what is the excess pressure of the liquid? Liquid drop, what is the excess pressure? 2S by R only here. So that 2S by R I have taken. Now PB you want to find out nothing but PB is equals to, pressure PB is equals to what I can say, PA minus 2S by R. Here what is PA? P0 minus 2S by R is a PB, pressure at point B. Now whenever you see exactly at the surface, let me take, this is the point C, just below the surface, just point C I will consider, C and then point D. Can I say C, D will have same pressure because they are the same level. However, it will have more pressure. How much more will be there? H rho G only. We will calculate that. Now I want to find out the pressure at this point. The difference of the pressure between the CB otherwise DB gives you what here means height of the water column. Finally, at the end of the day, you have to find out the height of the water column only, to how much height it is rising. That is what you have to find out. For that purpose, what I have considered nothing but, first of all, I consider the pressure at the top point and then pressure at this height, H, exactly H depth. Whenever I find out the pressure between them, then I can get the H automatically. What is the formula? H rho g only pressure difference is equals to. From that you have to find out the H value. For that purpose, what I am doing nothing but from where the liquid level is starting to rise, from there I am considering the points. So from here only liquid level is starting to rise. How much exactly extra height he got? Nothing but H height. That H only I want to find out. For that I have considered first of all the excess pressure between points A and then B. Why? Because I want to get surface tension also here. 2S by R indicates what? Here SE indicates what? Surface tension. Surface of the liquid also you have to get surface tension of the liquid. So here point A, concave side of the meniscus, point B and then convex side of the meniscus, outside of the meniscus and then inside of the meniscus. So here this is the concave side. At that concave side what happens? Nothing but there will be more pressure as compared to the convex side. Already we have discussed in the excess pressure only. So PA greater than PB. The difference between the more pressure and then less pressure, what is that? Is known as excess pressure. Difference between the pressures only we known as the excess pressure. So that P excess is equals to PA minus PB. What is the excess pressure for the liquid surface? 2S by R automatically. For the bubble you will get as how much? 4S by R. If you consider this as a bubble also, one side water is filled. Only how many surfaces are free? Only one surface is free. Anything you can consider. So that is how much here? 2S by R. Then PB is equals to P naught. PA is exactly how much? Nothing but exactly P naught only. Atmospheric pressure is acting on that. So P naught minus 2S by R. Now I wanted to find out this height. From this I did not get the height. I want to get the height means I have to take the another point also just below the H. So at this point I want to find out the pressure means what is that pressure? PD is equals to what I can say? PD is equals to what I can write? P naught plus rho g h, PB plus rho g h. P naught plus PB plus rho g h. In that PB only P naught is included. You are not getting surface tension at that time. See that here pressure is different, here pressure is different. Just below the surface I have considered. So from where you have to measure the pressure? Nothing but from here only. Why? Because in all the Pascal law applications whatever we are having, at that time we were having the liquid surface like this, and then whenever you take the top point, what was there here? P naught, and then bottom point we are having P naught plus H rho g. Why? Because pressure was distributed equally at that time. Here due to the shape, meniscus shape, what happens? Nothing but pressure will vary as compared to the outside and then inside. So only here the pressure is P naught. So here pressure is how much? P naught minus 2S by R. Pressure is decreasing there. You cannot take directly this pressure. Understand or not? Outside the pressure is more, inside pressure nothing but after of this meniscus I am taking about, at point A pressure is more. That is which pressure? Atmospheric pressure. Inside pressure is decreasing. Decreasing by how much here? Decreasing by how much? 2S by R. So that you cannot say that directly P naught plus H rho g we can take. That's wrong answer. So always you have to consider B is just started from the below surface only. So what I can say here clearly? PB plus H rho g. In PB only P naught included again. No need to take again and again. So that PB is equals to what we got here? PB is equals to P naught minus 2S by R plus H rho g. Here PD at point D is equals to what I can say? Point C. Not exactly inside, let me take like this. Okay, from there only it will start to rise. So actually it was there here, due to the adhesive forces it fallen down. So that you have to take outside only. Point C is there just outside, and then point D is there in the capillary tube. What I can say here? PC is equals to what I can say? PD. PC is equals to PD. And PC outside what is there here? Atmospheric pressure P naught is there. So that in the place of PC I can write it as P naught. P naught is equals to PD. So that in the place of PD what I can write? P naught. P naught gets cancelled. H rho g is equals to what I can say? 2S by R. Then H is equals to 2S by R rho g. And also they will not give this capillar here. What is this capillar indicates? Meniscus radius. This R indicates the meniscus radius. Meniscus total circle only not there for us. You should not get the answer in terms of that. They will give always the radius of the capillary tube only. So for that you have to get this answer in terms of capillary tube, radius of capillary tube. For that purpose you have to get the answer in terms of smaller. Any idea about that? Can anybody tell me that? ಫಾರ್ಮುಲಾ ನೆನಪಿದೆ ಎಲ್ಲರಿಗೆ, ಓಕೆ, ಬಟ್ ಹೌ ಇಟ್ ಈಸ್? So this is a meniscus we got. Whenever you got this as a meniscus, what is the R here? Capillary is nothing but what? The radius of the surface, not about the capillary tube, right? So for that, what I will do, nothing but I will just make it to fill. Complete circle I draw for that. I am very bad at the diagrams. Yenappa? So that is a radius of the surface is how much? Nothing but capillary here. But radius of the capillary tube is how much here? Small r, let us consider. Now this angle is here, theta is there. So what is that angle will be? What that angle will be? Anything you can take, that is a theta c only. Directly we will take it as theta c only. Theta c, let us consider, otherwise theta will consider. So whenever I take this as a theta, then this is r, means can I say capillary cos theta is equals to small r? For adjacent component of r only, right? Small r here. So that in the place of capillary, what I can write, nothing but r by cos theta. So that here h is equals to what I can say 2s by, in the place of capillary, small r divided by cos theta, means it will go up, and then into rho into g. This angle will be which angle? Nothing but that is the angle of contact. So how it will be? See that this is the theta c actually for us, that is theta c. The next angle will be how much here? This angle will be 90 minus theta c. Then obviously next one is what? Theta c only again. So only we got it as theta c here. So this is our formula, h is equals to 2s cos theta c by r into rho into g. Here s is what here? Surface tension of the liquid, whichever we considered. Theta c is what? Angle of contact. Then r is the radius of which one? Capillary tube. And also rho is the density of the liquid, and then g we have taken. And also if they might give even radius of the meniscus also. If they have given the radius of meniscus, at that time 2s by directly how much? What is the formula? R into rho into g. Clear? Copy that. मोइन सर आइन रे नहीं देख क्या जाता मुझे एक बार पानी लेके आओ ऐसे ಏನಂತ ಮಾಡಿದೆ ಹೇಳಿ ತರಕಾರಿ ಟೊಮೆಟೊ like that is telling. Yeah, this time you are feeling difficult in question paper. I'll discuss the paper, okay na? I'll discuss the paper tomorrow in the combined class only, because again separately I will not discuss that. ಕ್ಯಾನ್ ಸರ್ ನಾನು ನೋಡ್ತೀನಿ ನೋಡಿಲ್ಲ ಅಲ್ಲ ಅವಾಗೇ ಬಂದಿದ್ದೀನಲ್ಲ ಕ್ಲಾಸ್ಗೆ ನೋಡ್ತೀನಿ ಮಧ್ಯಾಹ್ನ ನೋಡೋಣ Finished? See that? Here, listen again. So here, whenever you see the meniscus here, I am saying outside and then inside, you don't confuse about that. Here, whenever you take the meniscus, for that meniscus, you can draw it as a complete circle only here like this. So whenever you take this meniscus, for this whatever the bubble if I consider, otherwise for this whatever the circle if I call, For that circle, A is inside and then B is outside. For the liquid, A is outside and then B is inside. Don't confuse in that. But always what I said whenever I was teaching about the excess pressure, concave side pressure will be more as compared to the convex side. So here concave side means point A, convex side means point B. Concave side pressure is more means PA greater than PB. The difference between them is known as what? Excess pressure. So that difference between them is the excess pressure I have taken. And then for example, if you consider that as a water bubble only. If I consider that as a bubble, inside air is there, but outside what is there here? Water is there. So only one surface is free. So what is the excess pressure here? 2S by R only. So that 2S by R I considered. And then after that, at point A we are having which pressure means atmospheric pressure exactly. So PA minus PB is equals to 2S by R. Then PB is equals to PA minus 2S by R. That is what the PB value we got. Then after that, now we have found the pressure, okay, pressure at the just below the free surface we have found. Then after that you have to find out the height of the water column, how much it is raised. For that height what you have to do nothing but you have to take the point C on the free surface and then point D on the same line but inside of the water. So both are having same pressure. Already we know that at the points at the same level will have the same pressure. So PC is exactly equals to how much here? PD. But at point C which pressure is there for us? Atmospheric pressure is there. So point D also same only as per whatever the statement we got. So that PD is equals to also how much? P naught. But PD is having more pressure than P naught. That is what we are getting here. P naught plus some value we are getting. Whenever you see PC at the PC is just open to the atmosphere, but PD is inside. Then you might think that on point D there is a more water, so how they can be equal? You might be thinking like that. Yes, they are not equal. So only we are getting extra value here. PD is equals to P naught plus some extra value here. Clear? So P naught gets cancelled here. H rho G is equals to how much will be there? 2S by R only. So from that 2S by R, so 2S by R and then divided by rho G obviously will get. Now this capital R value I have to get. For that capital R value, you have to take the entire circle. The circle of radius how much here? R. And then radius of the capillary tube is how much here? Small r. Now whenever you take the angle between them, angle is very important here. For the concave meniscus, where the angle of contact will get? For any meniscus, always between the liquid and then glass only. So this is the angle of contact here. Let me take this is the, for example, if I take this I consider horizontal level and then this is the theta C we are getting. This is theta means this will be how much? 90 minus theta C. Then automatically this will be how much here? Theta C only. That is what I have taken here, theta C. And then this is the capital R and then this theta C means this will be how much? R cos theta C is equals to how much here? Small r. Then in the place of capital R what I can write? R by cos theta C. Clear? That is about the capillary rise, how much it is raised. And also capillary fall will be there. Capillary fall nothing but whenever you consider the mercury and then glass, at that time what happening? What happening? Liquid level is how much it is having? Falling, right? Falling due to which forces? Cohesive forces are more as compared to the adhesive forces. So for example, let me take this is a outside mercury level and then here inside mercury is there like this. So this is falling to how much depth? Nothing but H depth, let us consider. From the free surface you have to consider exactly. From here H depth it is falling. That H value will be how much means again the H value will be how much? Same only, same values, both are same. Again 2t cos theta by R rho G only. Clear? And then that you have to find. I am giving to you to that work and then you have to find by taking exactly points where you will get the atmospheric pressure, where the pressure will be more. For example, if I consider this is point A and then B, where the pressure is more? Which side pressure will be more? Concave side. Concave side means which is concave side here? Point A. So that point A will have more pressure as compared to point B. So that PA minus PB is equals to what I can write? Again 2S by R only, there is no change in that. Now you just consider one point here exactly and then whenever you consider one point here, this point and then this point will have atmospheric pressure P only and then this fall only, this is only right our fall. So that here P naught atmospheric pressure, here how much will be there here? H rho G. This point, whatever the point D, point C I will consider, this one point D I will consider. Can I say point A is equals to pressure at A is equals to pressure at D? Both are the same level. but for the D you will get more pressure. How much pressure? Nothing but again P naught plus 2S by R plus H rho G only you will get. So that value only you have to find out. Clear? Here actually the main difference is here minus 2S by R you will get, there plus 2S by R, that's it. There is no difference in that, however it will get cancelled. Clear? And also here plus H rho G will be there, but here how much you will get? Nothing but minus H rho G. You are measuring in the depth, so that minus H rho G we have to take. Clear? That one you solve, but you should get the same answer only there also. Clear? Chalo. And tomorrow I will discuss the question paper. Don't worry about the question paper.